Hi there, as a part of AgilePoint's version 10 release, we're happy to announce support for Qwen. Now this is a companion video that will focus on using Qwen in the AgilePoint AI Control Tower. So if you're interested in learning how to create an access token or using the inline process activities, please do watch the other video. So let's jump into our demo scenario for today, which as always is an insurance claim application. Now we'll go through the various agents in just a moment, but the typical processing for a claim would be a customer calls into a call center to open up a new claim once they've had an accident. The process flows back to the customer where they'll provide more information about that accident, a detailed description, and any images showing damage to their vehicle, and a number of additional internal steps that we won't cover as a part of this video. Now, with all other AI platforms, we have both process activities, which are shown in the other video, as well as the AI control towers. And here we have two major categories. We have Analyze Image, which leverages computer vision and the ability to inject dynamic process behavior, adapt flow, inject ad hoc task, initiate dynamic subprocesses, and send notifications. And the same thing here from a chat completion perspective. Okay, now before we walk through the configuration, let's quickly understand the different roles these agents will play as a part of our claim. So first, we have an image classification agent, again leveraging computer vision to analyze the customer-provided image showing damage to the vehicle. The output of this agent will be fed into our claims analyzer agent, who essentially will make a comparison. How does that image line up to the customer-provided description of the accident? Now these two agents will hand their insights over to our final fraud predictive agent, which will make an overall fraud assessment. How likely is fraud in this claim? And in the event that it's likely, we'll see the typical processing paused and additional levels of review will be injected for our fraud investigation team. So let's get started with understanding our image classifier. So as you're seeing here, this is using the Analyze Image activity. Now the image itself will be passed from the AgilePoint form and uploaded into a repository. In this case here, we've configured Box. Now as you might expect, any of the other providers that are pre-integrated could be used here. And as you're seeing, we have a variable for the dynamic folder path. Okay, now I've selected how I'm connecting into Qwen using a global access token, various model parameters. Now moving into the system instructions, we'll see here this is a bounded and structured experience in comparison to the typical blob of text you might see in a traditional prompt engineering approach. But here the goals and mission are to analyze an image of a car that's been in an accident and to return a damage assessment for specific parts of the vehicle. The skills include computer vision, damage detection, visual inspection and classification, structured data generation, JSON, and rules-based decisioning. The input will be the image itself showing damage to a car. Various instructions, namely that we need to return a structured damage assessment for 9 distinct parts of a vehicle. Quality verification. So here we need to return an assessment for 9 distinct parts of that vehicle that each field shows exactly once, and to return a strict yes or no, and to format everything from a JSON perspective. Okay, now the output, again, going to be a JSON structure showing that structured damage assessment that we've talked about, and I have some sample values here. Okay, now the triggering event. Now the big difference here between the control tower and a process activity is that event-driven framework. So here, when the customer engagement step has been completed, though I could bring in additional filters. Nothing here from a request mapping perspective. Again, that image will be passed to our vision model from the form. The response here is a JSON structure, and we've mapped that back to our AgilePoint application. Again, showing those 9 distinct parts of the vehicle, mapped back to the corresponding nodes in my AgilePoint form. No parsing required in this case, though if I did store the entire response in a variable, I could parse out different elements. You're seeing different means by which I could do that here. And then nothing from an actions point of view. We just want the results to come back from this model. Okay, now the two remaining agents, the claims analyzer agent and the fraud predictive agent, are going to be pretty similar in configuration. We're going to walk through the fraud agent because it does introduce some dynamic process behavior. Okay, so again, I've connected into Qwen. I'm specifying the model that we prescribed at the access token level. Again, for manageability, really means one place to change the model as opposed to multiple applications, multiple activities, multiple control towers, things of that nature. And again, moving into the system instructions. So here, the goal is to look at the claim as a whole, to look for indicators of fraud, anomalies, inconsistencies, unusual patterns, and to make a final fraud prediction. Various skills include things like insurance domain understanding, fraud pattern detection, various types of analysis, clear, explainable decision making. You're seeing here the input, a JSON structure, a lot of the details from the policy as well as the claim itself. How to analyze for fraud, so specific instructions. Quality verification, basically saying arrive at a conclusion based solely what is in the claim, make no assumptions, and to have clear reasoning across similar claims. And then the output, again, going to be a JSON structure where we want to return a fraud prediction and a probability. Okay, so our triggering event here is going to be when the wait for milestone activity is completed. Okay, so for the request mapping, we've intelligently brought over the JSON structure from my system instructions. And then you're seeing here, I can map that for my request. Now, from a response perspective, what we want is a prediction and a probability, which again has been mapped back to the AgilePoint side. No parsing required in this case. And then the actions. So here's where we bring guardrails around how AI is going to impact our application. When fraud is likely, we're going to run a sub-process, which, as mentioned, brings in additional levels of review for our fraud team. But again, we did bring some guardrails. So here, when we have a claim that is potential fraud, how do we determine when to bring in that dynamic sub-process? So when the fraud prediction equals true and the probability is greater than 50%, or when the detailed accident description perhaps was submitted by a large language model, right? In other words, not human. Or when there are key conflicts. So as an example, what you're going to see is the image might show one thing versus the description of the accident indicates another. Okay, so now that we understand how our control towers have been configured and the corrective action they're going to take against our application, let's go ahead and run it. Okay, so a customer has had an accident, they're called into the call center, and I want to retrieve the details of their policy. We'll specify the vehicle in the accident and the driver's name. Capture initial details, and again, recall that the customer will provide a more detailed description as a next step. Any witnesses, the third party involved, prior claim history, and lastly, we'll just leave a comment and open up a new claim. Okay, so our new claim has been opened. Let's follow along with the process viewer. Okay, so we've just opened up a new claim, which means that we're now sitting with the customer engagement step. So playing the role of the customer, I've received an email where I'll be prompted to provide an image showing the damage to my vehicle and a description of the accident. Okay, so here's the image that we'll use. Pretty clear damage to the front of the vehicle shown here. So let me upload that. Now while that's uploading, at the bottom we have a more detailed accident description. So what I'd like to do is introduce very clear conflict between what's shown in the image and the description. So I'm going to remove the front of the vehicle and indicate that the back of the vehicle was damaged. Okay, now going back into our process tracker, we'll see indicators for our various control tower agents light up as they're invoked. Okay, so all 3 agents have fired. And as you're seeing here in my process viewer, the typical next step would be with the claims handler activity. However, if I go back into my task list, we're going to see a couple of new tasks have landed in my bucket. In fact, if I try to open up that claims handler step, I'm going to be met with a warning indicating that this process has been paused, fraud is likely in this claim, and this task won't be unlocked until the exception has been handled. So now a subject matter expert has had a task allocated to them. Similarly, we'll have some guidance here at the top left-hand corner of our form indicating why a task has been dynamically routed to this user, and to basically review the insights that have come back from AI. So of course, we have the image that we provided earlier. Now under the damage assessment, we're seeing all of the insights uncovered by our computer vision model. Now under AI analysis, we're going to see the outputs from our claims analyzer agent. So here we do see that the report was authentic, right? It has been written by a human. However, there are some pretty key conflicts, and we talked about that a few moments back. Now under ad hoc adaptation, the control tower is suggesting we inject additional levels of review. In this case here, the control tower is operating with a human brought into the loop, though be mindful of the fact that these actions can always be taken autonomously once enough trust has been developed. So I'll go ahead and accept the suggested change. We'll inject new tasks with the investigation team, and I want to keep the lock on all of those downstream steps. So now behind the scenes, the AgilePoint engine is injecting yet another task for review, and we'll see that show up in my task list in just a moment. Okay, so here's that task. So at this point, I'm playing the role of the fraud investigator. I'm going to leverage, again, all of the insights AI has uncovered for me and my experience as a fraud investigator. So we'll take an offline action to review fire and police reports and determine how this claim goes forward. Now, of course, we could reject the claim if we concur with that fraud assessment. However, in my case, I think this is a customer who's just a bit frazzled after having had an accident. So I'm going to allow this claim to proceed. And what we're going to do now is essentially unlock those downstream steps and allow the process to continue as normal. Now, before we close the video, I do want to highlight the different ways in which we can view the audit trail information for an AI control tower when it takes corrective action against an application. So if I go back into our process monitor, we'll see here we have the adaptive orchestration monitor. This gives us a visual understanding of how AI is impacting our application. So as an example, we can see here, this agent ultimately invoked a dynamic subprocess when fraud was found to be likely. However, in addition to that visual audit trail, AgilePoint also maintains these details on a textual basis as well within Manage. So what I have here is I run a search for this instance of the application, and you'll notice we have a control tower tab. So here I see all 3 agents, and I can always investigate all of the details. In other words, the inputs, outputs, actions taken, and things of that nature. Very handy from an auditing perspective in case I need to prove down the line why an agent took action against a process and the action that it took. However, with all of these details, I can always leverage this for ongoing model retraining. Okay, so with that, this is going to conclude the content for this video. Thank you so much for watching. I hope this gives you a better understanding of how to use and configure the Qwen AI control towers and how to understand all of the audit details captured whenever a control tower takes action.